A transparent medium shows a relation between I and R as shown. If the speed of light in vacuum is c, the Brewster's angle for the medium is. So as we know that the tangent of the Brewster's angle is equals to the refractive index of the medium. But by this graph we can understand that is the slope of this graph, that is, let me consider the slope of the graph gives us sin r by sin I, that is slope that is the m, that is m is equals to sin r divided by sin. So this is nothing but sin r by sin I is equals to slope is nothing but tan 30. But here we have seen that is tan theta b is equals to n is refractive index is nothing but the ratio of sin I and sin r. So we can write here the sin r by sin I here, but here we have sin I by sin r, so therefore we can write the sin I by sin r is reciprocal of tan 30. So we have a tan 30 value, that is 1 divided by root 3. So this is nothing but root 3. So that is tangent of the Brewster's angle is equals to root 3. So therefore Brewster's angle is equals to tan inverse of root 3. So tan inverse of root 3 is nothing but tan inverse of root 3 is 60 degree. So option C is the correct answer. Okay. Moving to the next question, that is in Young's double slit experiment using monochromatic light of wavelength lambda, the intensity of light at a point on the screen where path difference is lambda is k units. The intensity of light at a point where the path difference is lambda by 3 is. Here the intensity of light I is equals to k units when the path difference is equals to lambda. In the same way, they are asking you to find out the intensity at a path difference of 3 by lambda, or lambda by 3, that is lambda by 3. As you know that the intensity is equals to, the resultant intensity is equals to I1 plus I2 plus 2 root I1 I2 cos psi, where psi is the phase difference, and I1 and I2, these two are equal because we are using monochromatic light. So whenever we are using monochromatic light, we could write I1 is equals to I2, so therefore it will become 2I1 is equals to I2, so it will become 2I1 plus root I2, in place of I2 I am writing I1, so therefore it will become I1 square cos psi. So what is the value of psi here? If it is lambda, we have a relation for phase difference and path difference, that is phase difference is equals to 2 pi by lambda into path difference. So here we have 2 pi by lambda into, here we have lambda. So if I substitute here, the delta psi, that is phase difference, will become 2 pi. So therefore this is equals to 2 pi. Now in this case we will get 2I1 plus this is equals to 2I1 and cos 2 pi is 1. So this is equals to 4I1. So this is what resultant intensity is for this as mentioned as k units here. Now in the second case we can see that that is resultant intensity is equals to, here the same thing, we are using the same light, so therefore we can write directly 2I1 plus here we have 2 root I1 square, and here we can write cos 2 pi. In place of psi we need to write now, so in place of psi what we can write, here we have, in this case we can write delta is equals to 2 pi by lambda, and then delta x is equals to lambda by 3. So lambda by 3, lambda get cancelled, we'll get 2 pi by 3. So in place of this one we have to write 2 pi by 3. So 2 pi by 3 is nothing but 120 degrees. So we can write now here 2I1 plus 2I1, and here cos 120 is minus 1 by 2. So 2 1 ja 2 1 here. So therefore minus I1, 2I1 minus I1, this is equals to I1 only. So here IR is equals to I1. So this I1 can be written as, here you can see that 4I1 is equals to K. So therefore I1 is equals to K divided by 4. For that reason here also you can write K divided by 4. So option K divided by 4. So option B is the right answer. Okay, moving to the next question. Due to Doppler effect, the shift in wavelength observed is 0.1 angstrom for a star producing wavelength 6000 angstrom. Velocity of recession of the star will be. So as we know that the Doppler shift can be expressed in terms of wavelength, that is delta lambda divided by lambda is equals to plus or minus V radial divided by C. Here delta lambda is Doppler shift, lambda is the wavelength of the light, and then V is the velocity of approach or velocity of recession, and C is the speed of light. Now we need to consider the positive when the source is moving away from the observer, and we need to consider the negative when the source is moving toward the observer. So here the velocity of recession we need to find out, that is the source is moving away from the observer, so therefore we must consider here positive. So what will happen, let us see, delta lambda divided by lambda is equals to plus V radial divided by C. So now we can find out V here, so make V as a subject formula here. So what will happen, delta lambda divided by lambda into C, and substituting the values now. So delta lambda here we have 0.1 angstrom, and lambda here 6000 angstrom, and C as we know that 3 times 10 power 8 meter per second. So here angstrom get cancels, and here 10 to the power of 8 we have, and here 3 zeros will go, so it will become 5 now. So now 3 1 ja, 3 2 ja, so 0.1 divided by 2 is 1 divided by 20 into 10 to the power of 5. So this can be written as, so 100 divided by 20 into 10 to the power of 3 we can write. So it will become 100 divided by 20 means 5 into 10 to the power of 3. So 3 meter per second. This can be written as 5 kilometer per second. So here the option C is the right answer. Okay, moving to the next question, that is, an electron is moving with an initial velocity V vector is equals to V naught I cap, and is in a uniform magnetic field B vector equals to B naught J cap. Then its de Broglie wavelength increases with time, increases and decreases periodically, remains constant, and decreases with time. As we know that the de Broglie wavelength is equals to H divided by mv. Here a charged particle is entering the magnetic field along the x-axis, because I cap the diagonal along the x-axis it is entering, but the magnetic field is acting along j direction, that is j cap, along like this, it is acting along y direction. So therefore the direction of the velocity of the electron and the direction of the magnetic field is perpendicular to each other. As you know that whenever the charged particle is entering the uniform magnetic field perpendicularly, at the time the charged particle possesses circular path. Whenever the charged particle is moving in the circular path, there will be change in the direction only, but there won't be any change in the speed. Its speed remains constant, but its direction changes every instant of time. So therefore the speed doesn't change, but the de Broglie wavelength depends upon the speed of the charged particle. So here the speed doesn't change, so therefore the de Broglie wavelength remains constant. So option C is the right answer. Moving to the next question, that is, light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. If both the frequency and intensity are doubled, the photoelectric saturation current becomes. As you know that the photoelectric current is directly proportional to the intensity of incident radiation, and it does not depend on the frequency of incident radiation. So therefore if the intensity doubled, then the photoelectric saturation current also doubled. So therefore option B is the right answer. Moving to the next question, that is, a magnetic needle has a magnetic moment of 5 into 10 to the power of minus 2 ampere meter square and a moment of inertia 8 into 10 to the power of minus 6 kg meter square. It has a period of oscillation of 2 seconds in a magnetic field B vector. The magnitude of the magnetic field is. So as we know that the period of oscillation of a magnetic needle in the magnetic field is given by the expression that is T equals to 2 pi square root of I divided by I by mb. See here, squaring on both the sides, we will get 4 pi square I by mb. Here actually we need to find out magnitude of the magnetic field, so therefore make B as a subject formula. So therefore B will become B equals to 4 pi square I divided by mt square. On substituting the values, that is 4 pi square, it is nearly equals to 10, and I, so here the moment of inertia is 8 times 10 power minus 6 divided by m, the magnetic moment is 5 into 10 to the power of minus 2 into t square. T square is the 2 second, that is 2 2 ja 4. So 4 and 4 get cancels, 5 1 ja, 5 2 ja, and 2 8 ja 16. So this is equals to 16 times this is 10 to the power of minus 6 divided by 10 to the power of minus 2 into 10 to the power of minus 4 Tesla. So the magnetic field is 16 into 10 to the power of minus 4 Tesla. But here there are no such type of options. So therefore, which carries Grace marks. So if it is, that is 1.6, instead of that, if it is 16, then it would be the right answer. Okay. So let me move to the next question, that is, a toroid has 500 turns per meter length. If it carries a current of 2 ampere, the magnetic energy density inside the toroid is. So as we know that the magnetic energy density is given by the expression that is U naught is equals to B square divided by 2 mu naught. So here the magnetic field inside the toroid is given by the expression that is mu naught Ni. But here we have B square, so therefore make it square. So that's mu naught square N square divided by I square divided by 2 mu naught. And here this mu naught and 1 mu naught from the numerator will go, and then you will get the mu naught N square I divided by 2. I'm substituting the values, that is mu naught value is 4 pi into 10 to the power of minus 7 into N square. Here N we have 500, so therefore 500 square into I is equals to 2 ampere, so 2 square divided by 2. This 2 get cancelled, we'll get the 4 pi, that is 4 into 3.142 into 10 power minus 7 into 500 square. 500 square is nothing but 25 into 10 to the power of 4, that is 20 to the power of 4 into 2. So now here we have 25 and 4, this is equals to 100. So 100 into 10 to the power of 4, 10 to the power of 6 it will become. So therefore here we can write 3.142 into, we have here 2 into 10 to the power of 6 into 10 to the power of minus 7, it will become 10 to the power of minus 1. So we have here 3.142 into 2, that is 6.284 into 10 power minus 1, that is what, 0.6284 joule per meter square. So here option 628. So option A is the 0.628. Option A is the right answer. Okay, moving to the next question, that is, consider the situation given in the figure. The wire AB is a slide on the fixed rails with a constant velocity. If the wire AB is replaced by semicircular wire, the magnitude of the induced current will be. As you know that whenever the wire AB is moving in the direction perpendicular to the direction of the magnetic field, then the induced EMF, that is motional EMF, is given by E equals to BLV. So this L is the perpendicular distance. This AB is the perpendicular distance. So even if you change or if you replace this AB by semicircular wire, then the perpendicular distance, this AB will not change. This AB, this perpendicular distance will remain the same. If this distance remains the same, at that time the EMF induced in the coil will be remain same. So therefore the resistance will remain same here. There won't be change in the resistance. If the resistance remains same, then current, that is induced current, will also remains same. So therefore option B is the right answer. Moving to the next question. The frequency of an alternating current is 50 Hz. What is the minimum time taken by current to reach its peak value from RMS value? As we know that the peak value is, let me take, this is the peak value, this, let me consider this is V naught, and here in the middle you can see the RMS value, and then the time taken by the current to reach its peak value is T by 4. So T by 4. Now we know that the Vrms is equals to Vrms is equals to V naught sin omega t. So as we know that the relationship between peak value and RMS value of the voltage, that is V naught by root 2. This is equals to V naught sin omega t. Here V naught get cancels, and we'll get sin omega t equals to 1 by root 2. If sin omega t equals to 1 by root 2, then omega t is equals to 45 degree. That 45 degree can be written as pi by 4. So therefore here omega is nothing but 2 pi by t. 2 pi by t into t equals to pi divided by 4. Pi get cancels. So this small t will become t equals to, so capital T divided by 2 4 8. So 8. This is the time taken by the current to reach its maximum value from the 0, that is from the minimum value. But we need to find out that minimum time taken by the current to reach its peak value from the RMS value. So therefore we need to deduct that this time from T by 4. So therefore the time taken to reach its minimum time taken to reach the maximum value from the peak value is equals to T by 4 minus T by 8. Now T by 4 minus T by 8 is T by 8 only. So now we can express this T in terms of frequency, that is 1 divided by F into 8. This is 8. So already we have F here, frequency we have here, that is 50 Hertz. So therefore substituting we'll get 1 divided by 50 into 8. So therefore 50 into 8 is 400. So therefore the minimum time is equals to, that is equals to 1 divided by 400. So 1 divided by 400, that is equals to 1 by 4 is 0.25. 1 divided by 100 can be written as 10 to the power minus 2. So this can be written as 2.5 into 10 to the power minus 3 second. So therefore option B is the right answer. Moving to the next question, that is the readings of ammeter and voltmeter in the following circuit are respectively. So here by looking at the diagram, here we can see that the voltage across the inductor and capacitor is same. So therefore this is a pure resistive circuit. So therefore the voltage across the resistance is 220 volt only. Or else we can find that is V total is equals to VL minus VC whole square plus VR square. This is equals to, we can write VL minus VC is 0. So VR square, square root of VR square is VR only. So therefore VR. It is V total, that is voltage, total voltage equals to across the, that is voltage across the resistance. So therefore here V equals to how much? V is equals to 220 volt, that is 220 volt. Now we need to find out the ammeter. So this, we know that I is equals to V divided by R. So here we just now we got V is equals to 220 volt divided by R. So R value is 100. So therefore we will get 2.2 ampere. So option D is the right answer, that is 2.2 ampere and 220 volt. Okay, moving to the next question, that is two particles which are initially at rest move towards each other under the action of their mutual attraction. If their speeds are v and 2v at any instant, then the speed of the center of mass of the system is, let me consider two particles A and B which are moving towards each other with a speed of v and 2v because of their mutual attraction. They are moving towards each other under the action of their mutual attraction. That means there are no external forces acting on the system of the particles. Okay, so initially these two particles were at rest. So the initial momentum of these two particles or the center of mass of these two particles is 0. So momentum is 0. And we know that there are no external forces acting on them. So the momentum, final momentum is also 0. They are moving just under the action of their mutual attraction and there are no external forces acting on them. And one more thing, the mass could not be 0. So velocity will be equals to 0. So velocity is 0. So option B would be the right answer. Option B is the right answer. Moving to the next question, that is, a particle is moving uniformly along a straight line as shown in the figure. During the motion of the particle from A to B, the angular momentum of the particle about O is. See here, the particle is moving from A to B in a straight line path, but they are asking you to find out the angular momentum of the particle. The angular momentum is related to the rotational motion. So for a particle moving in a straight line path, the angular momentum is always remains constant. Keep in mind that the angular momentum of a particle moving in a straight line path remains constant, but the change in the angular momentum of the particle remains 0 for a particle moving in a straight line path. But the particle is moving in a straight line path and they are asking you to find out angular momentum, so angular momentum remains constant for a particle moving in the straight line path. So option C is the right answer. Okay, moving to the next question. A satellite is orbiting close to the earth and has a kinetic energy K. The minimum extra energy required by it to overcome from the gravitational pull of the earth. As you know that the escape velocity is equals to root 2 times the orbiting velocity. The kinetic energy of the satellite when it is orbiting around the earth, that is the kinetic energy when it is orbiting is equals to half mass of the satellite into orbiting velocity square. This is, now this is equals to how much? They are saying that this is K. Now just to overcome the gravitational pull of the earth, so the kinetic energy required to escape from the gravitational pull of the earth is equals to half mve square. So here this ve is nothing but that is half m v. Just now we have seen that root 2, that is root 2 v naught whole square, and this can be written as 1 divided by 2 m that is 2 into v naught square. So therefore this will become 2 times of 1 by 2 m v naught square. This half m v naught square is equals to how much? Half m v naught square is equals to k. So therefore this will become 2k. That is the kinetic energy required to escape from the gravitational pull of the earth is 2k. But the question is the minimum extra kinetic energy required by it to overcome from the gravitational pull. So extra kinetic energy needed is equals to, that is extra kinetic energy needed to escape from the gravitational pull of the earth is equals to the kinetic energy required to escape from the gravitational pull of the earth, that is 2k, minus the kinetic energy while orbiting around the earth, that is equals to k. So option A is the right answer. Moving to the next question. A wire is stretched such that its volume remains constant. The Poisson's ratio of the material of the wire is. We know that the Poisson's ratio is equals to the ratio of lateral strain divided by linear strain, that is longitudinal strain, change in length divided by original length. So as we know that whenever the wire is stretched, so let me assume that it is in the form of cylindrical. For a cylindrical wire we have a volume, that is volume of the cylindrical wire is equals to pi r square L. So change in the volume, whenever we stretch at the time there will be change in the volume, there will be change, whenever we stretch at the time there will be change in the radius, there will be change in the length. So we can write that change in the volume divided by original volume is equals to, here we can write 2 delta r divided by r and plus delta L divided by L. We could write like this. When we write in the algebraic equation form, we will get like this. Now, there is no change in the volume, that is change in the volume is 0. The volume remains constant, So this will become 0. So this is equals to, that is 2 delta V delta R divided by R plus delta L divided by L. So therefore we can write here this is equals to what is delta L divided by L is equals to minus 2 delta R divided by R. So here this can be written as that is equals to, that is delta R divided by R divided by R is equals to 1 divided by minus delta R divided by R is equals to 1 divided by 2 delta L divided by L. So you could write this one as like this now, delta R divided by R whole divided by delta L divided by L. This can be written as 1 by 2. So this is the ratio. This is equals to the Poisson's ratio. So Poisson ratio is equals to minus delta R divided by R whole divided by delta R divided by, so delta L divided by L. That is the lateral strain divided by longitudinal strain is equals to 1 by 2. 1 by 2 is nothing but 0.5. So option A is the right answer. So moving to the next question, that is a cylindrical container containing water has a small hole at height of h equals to 8 centimeter from the bottom and at a depth of 2 centimeter from the top of the surface of the liquid. The maximum horizontal distance traveled by the water before it hits the ground is. So we need to find out maximum horizontal distance traveled by the water before it is going to hit the surface. Let me consider that one as x. So we know that the distance is equals to velocity into time. Here the velocity of the liquid or speed of efflux we need to find out. The speed of efflux is equals to, it is v square is equals to u square plus 2g height of the liquid from this point. This is h. So here the speed of the liquid, initial speed of the liquid is 0. So therefore it will become v equals to root 2gh. So I am writing here in place of v, it is root, the speed of efflux is equals to 2gh. Now let me take time taken by the liquid to reach this level is equals to how much? That is h is equals to, that is height, this height is equals to ut plus of gt square. So initial velocity is 0, so therefore it will become 0. Now this is equals to, that is 2h is equals to gt square. So therefore t equals to 2h divided by g, that is whole root 2h divided by g. So therefore in place of t I could write here 2h divided by g, root 2 divided by g. Now here root g and this root g will get cancelled. On substituting, that is 2 into h, the small h is here, they mentioned here 2 centimeter, this is equals to 2 centimeter and this is equals to 8 centimeter. So I am substituting h is equals to small h equals to 2 into root capital H is equals to 8. So this will become 4 is nothing but 2 into, it is 4, this is equals to 8 centimeter. So option A is the right answer. Moving to the next question, that is an inductor of inductance L and resistor R are joined together in a series and connected by a source of frequency omega. The power dissipated in the circuit is, as you know that power is equals to VI. So as you know that V equals to IR, so therefore it will become I square R, that is P equals to I square R. Power is equals to I square R, and here I is equals to V divided by impedance, that is Z. And here this is a LR circuit, so therefore we can write Z equals to root R square plus XL square. This is nothing but V divided by root R square plus omega square L square. So same I am substituting this formula in this expression, that is I square. So in place of I am writing V divided by root R square plus omega square L square, this whole square into R. And here we have this root this square for both, so we can get V square divided by this root and square will get cancelled, we will get R square plus omega square L square into R. into R. So therefore, that is power is equals to V square R divided by R square plus omega square L square. So option B would be the right answer. Okay, moving to the next question, that is, an electromagnetic wave is traveling in x direction with electric field vector given by Ey equals to E naught sin kx minus omega t j cap. The correct expression for the magnetic field vector is, as we know that electromagnetic wave is a wave which is consisting of magnetic field and electric field. Both are perpendicular to each other and they are perpendicular to the direction of the propagation. So here the electric field is along y-axis and the direction of the electromagnetic wave is x-axis. Then the magnetic field vector or the magnetic field must be along z-axis, that is Vz and Vz. Here are the two options. Among these two, one will be the correct answer. That means the magnetic field vector must be acting along z-axis. Now, as we know that the speed of the light is given by E naught divided by, that is amplitude of the electric field divided by amplitude of the magnetic field. So therefore, B naught, that is amplitude of the magnetic field is equals to E naught divided by C. So therefore, V naught equals to amplitude of the magnetic field vector is equals to E naught divided by C. Here E naught divided by C is the amplitude of this vector. So therefore, option D is the right answer for this question. Moving to the next question, that is, the phenomenon involved in the reflection of radios by ionosphere is similar to reflection of light by plane mirror, total internal reflection of light in the air during a mirage, dispersion of light by water molecules during the formation of a rainbow, and fourth, scattering of light by air particles. As we all know that the formation of mirage is a smaller and inverted version of reflection of radios in the ionosphere. So option B is the right answer, because here the total reflection of light in the air during mirage is similar as that of the reflection of radios by the ionosphere. So option B is the right answer. Moving to the next question, that is, a point object is moving uniformly towards the pole of a concave mirror of focal length 25 cm along its axis as shown below. The speed of the object is 1 meter per second. At t equals to 0, the distance of the object from the mirror is 50 cm. The average velocity of the image found by the mirror between the time t equals to 0 and t equals to 0.25 second is, here the focal length of the concave mirror is 25 cm, that is f equals to minus 25 cm. That is the focal length. Here it would be, this is a focal length from here to here, that is 25 cm. Now the object is placed at a distance of 50 cm from the concave mirror, that is object is placed at a distance of 50 cm, that is nothing but the focal length is 25 cm and object is placed at 50 cm. So that is, the object is placed at the center of curvature. If the object is placed at center of curvature, the image will be formed at the center of curvature only. That means at t equals to 0, the image distance as well as object distance is same, that is at center of curvature. The object is at center of curvature as well as image is at center of curvature. Now, whenever the object moves with a velocity 1 meter per second and it travels a distance of, that is s is equals to v into t, that is velocity is equals to 1 meter per second and time equals to 0.25 seconds. So this is equals to 0.25 meter. This is nothing but 25 centimeter. So if it moves through a distance, that means at a time 0.25 second, the object is moved through a distance of 25 centimeter. Now after 0.25 second, the object is at focus. If the object is at focus, we know that the image will be formed at infinity. Whenever the object travels through a distance of 25 centimeter, the image will be formed at infinity. The distance traveled by the image will be infinity. So therefore, the average velocity is equals to the distance, that is average distance, that is 25 centimeter plus the distance traveled by the image is infinity divided by time is equals to how much? Infinity. So therefore the average velocity of the image formed by the mirror between the time t equals to 0 and t equals to 0.25 second is infinity. The image is formed at infinity, so velocity of the image will be equals to infinity. Okay, moving to the next question, that is, a certain prism is found to produce a minimum deviation of 38 degree. It produces a deviation of 44 degree when the angle of incidence is either 42 degree or 62 degree. What is the angle of incidence when it is undergoing a minimum deviation? Here the angle of minimum deviation, that is D equals to capital D equals to 38 degree we have. So now the prism produces a deviation of 44 degree when the angle of incidence is either 42 degree or 62 degree. We have a relation, that is deviation produced by the prism is equals to I1 plus I2 minus A. Here I1 and I2, if you interchange this one, if you are getting the same angle of deviation, then we could consider like this, that is 44 degree is equals to I1, the first angle, that is 42 degree, plus I2 is the second angle, that is 62 degree, minus E. So we will get, that is 44 degree is equals to 104 degree minus E. So A is equals to 104 minus 44 is equals to 60 degree. This is angle of the prism. So after getting angle of the prism, we can find out the angle of the incidence directly, that is I is equals to, as we know that I is equals to A plus D divided by 2. So we have A is here 60 degree plus angle of minimum deviation is 38 degree. So 60 plus 38 is 98, 98 divided by 2, 49, that is 49 degree, that is angle of incidence. So option C is the correct answer. Okay.